welcome to EyeWire 2, Revenge of the Retina, the sequel to EyeWire 1.
Dun
Um,
dun dun. Sorry.
and we have some images of some of our cells over here on the right. So you can kind of see the shape of our whole data set over here, which is pretty cool. All right. So this is the data set size as compared to EyeWire 1. Um, so As you can see, this is a image from our preprint paper that just came out, the EyeWire 2 preprint paper. And then you can see over here, this is the EyeWire 1 data set and the size of it over here as compared to the EyeWire 2 data set. So you can see the great size difference that we're working with here. EyeWire 1 was 350 by 300 microns, and EyeWire 2 is about 1,000 by 1,000 microns, so much larger. And the benefit of that is obviously much more cells that to be proofread that have been proofread. Um, and uh, because we're not working in the cube system on EyeWire 2, the AI is much more powerful and is able to reconstruct much more of the cells at once. And then we're also able to get much more um, of a visual on these big wide field cells, like this example one here, and then also a lot more examples of some of our smaller cells, like this starburst cell that you're seeing here. So we'll have, EyeWire 1 had a bunch of examples of these types of cells, and then EyeWire 2 will have many more. So we get more instances of various cell types, which is great, and a bigger picture on some of the wide field cells. And then I also think the value of having EyeWire 1 and now EyeWire 2 is that it allows for future comparisons between multiple animal models. So that's great as well. Let's see. Okay. So this is just a kind of overview of the cell layers. Um, so this is a visual of the retina. Um, you have the photoreceptors up here. Those are not part of our data set, but our data set is working down here in the INL, IPL, and GCL. So that's the ganglion cell. The somas are down in this layer. And then the INL is another layer that has somas. Um, and then in between, you have mostly the branches of the cells. Um, so this is the whole retina that you're seeing here. This is our area of the data set. And then this is also from the paper, and you can see the EM images and the EM stack of those images. And then here is an example cell that you can pull out through the images. So another benefit of EyeWire 2 is that it contains functional data. So these small clusters that you see here, which are part of the data set and then are also um, visualized in the graphic over here as these blue boxes. Those are areas of the data set where there was visual stimuli recorded prior to the EM imaging of the data set. So from these specific areas, we can learn more about the functioning of these cells than, just having the static data. So that's another cool thing about EyeWire 2. And these are some differences between EyeWire and EyeWire 2. EyeWire is cube-based, consensus-based. has multiple checks and has a built-in log and database, the Scouts log, where people are able to put in data. It also has chat and leaderboard. In EyeWire 2, you're going to, for the most part, be working on your own cell. So rather than work on a cell with the community, you're going to have your own cell. We generally don't use consensus. There are times when we might have multiple people check the same cell, or you might ask for help and have a second person check maybe areas of the cell that you are having trouble with. But in general, we're not having a consensus system like we had in EyeWire 1, where multiple people are doing the same thing, and then we're pulling out an answer based on, the majority of people agreeing on what belongs or doesn't belong to the cell. Um, so for beginners, we might have somebody looking over your work. For advanced users, we generally trust that you are able to, proofread the cells by yourself, and advanced users are the first and last stop on the project. Right now, we're using a lot of spreadsheets to share information. We have a forum that's a place to share information as well. People have been using comments on the spreadsheet to talk about things they might have issues with. But we're, planning to build more tools in the future for communication and for uh, citizen scientists to use, also researchers. I think, communication tools are helpful for everybody, of course. So that's something that we'll have in the future. And then here's just an example of EyeWire and EyeWire 2. So here's a cell from EyeWire 1, and there's a cube included, so you can see what that's like, the portion of the cell that you'll be working on in any given time in EyeWire if you're playing cubes. And then EyeWire 2, this is an example of a starburst cell that the pink part that you're seeing is how the cell came in. So this is how much of the cell was reconstructed before anyone had touched it. I can see at least one visual merger on it. So that is something that the cell, unlike EyeWire 1, where you're sort of building the cell out from the soma. In EyeWire 2, a lot of the cell is built, and you're doing both additive and removal activities. So in this cell, you would want to remove this merger that is here, and there might also be some smaller mergers that are less visible. And then you're going to want to extend any branches that don't have extensions on them. So um, as you can see, something like this, there's a lot less work to do on it, though you do need to do a lot of checking of branch ends to make sure that they're complete. But it takes a lot less time just because of how much is already done on the cell.
If I may, we find that for EyeWire 2, the difference between the two is that the AI and the ability for all these things to be done, the technology for handling it, and the vast amount of data has, improved greatly since at this point, 15 years ago when EyeWire 1 was done. So we find with these EyeWire 2 cells, they're about somewhere between 80 to 90% fully reconstructed already by the what we call the AI, or by the computer. And so kind of what everyone is coming in with is they're finishing, you're coming in to do that last, 15 to 10% or so of getting the cell to a state of relative completion. Even as we know with EyeWire, we have cells that I know most of our citizen scientists that are here right now are scouts, so you're aware of what a duplicate is. So we sometimes, find a cell where an error was made and we got to go fix it in a really old one, and then it's better in the new one. And that's an iterative process still. And EyeWire 2, even if it isn't consensus based, and as Celia said, with advanced folks, that's kind of the last stop with only one person playing it. it's still iterative. So, if an error is found later on and a branch needs to get added or removed because it's found a better place in another cell or something, that can be edited again. So, something to kind of think about and not worry about is that it's not going to ever be perfect. It's not going to be ever 100%. And if you miss a few small little things, hopefully they'll get caught later on, or in some cases, they might just be so small that it's not going to affect, the data as a whole. So I just wanted to mention that, especially as you kind of look at the scale of these. And I know for a lot of folks, we're used to the little tiny cube and being like, oh my gosh, now I'm going to take out a whole branch. Well, really, it's just the fact that the computer is much better at connecting the dots, and now we're just fixing the same kind of mistakes, but they're just at a slightly bigger scale. So, sorry, Celia, I didn't mean to interrupt, but
No,
just a little explanation.
that's a good point. Yeah, it is good to note that even though you're sort of, once you like become proficient with these cells, you might be the first and last stop on considering something complete. It's true that in the future, if, there are errors found or somebody's using the cell and they're like, we really need a second look on this, there is always, nothing is ever 100% complete. We can always go back and add or remove things as needed. So that's a good point. All right. Next, so this is just the EM imagery that you see in EyeWire 1 versus EyeWire 2. So this is the EyeWire EM imagery that we have in regular EyeWire, the E2198 data set that all you guys should be familiar with. You can see it's pretty drastically different from the imagery that we have on EyeWire 2. If you're a Mystic player, you might be familiar with the zebrafish data set, which also has pretty nice looking EM. Um, so this is, a lot closer to what you'll be working with in EyeWire 2. Um, but you can see that the imaging in EyeWire 2 allows for a lot more information that we don't have in original EyeWire. You can see a lot of the internal structures of the cells, mitochondria and other various internal organelles in the cells that also are beneficial for scientific research. Can see the synapses clearly in this data set. So that's a big improvement and also has a lot of scientific benefit that we're able to get out of EyeWire too. So I think it's pretty cool to see the transformation of the EM um, over data sets. But that's just me. All right. Okay, so here is the EyeWire 2 interface. We'll go over this a little more when I do a little introduction to the Cilia project. That will be the introductory project for you guys. But I just wanted to sort of give an example of what you're going to be looking at. This image is also in some of our tutorial materials. Um, but basically, you should probably be pretty familiar with this layout, which we have the EM on one side and the 3D imaging on the other side. EyeWire 2 also allows you to insert the EM into the 3D model so you can see the 3D is coming through and you can probably see the cross section is the same as this cross section here. So that's an available feature for you. You can also turn this off if you don't like it using the sections button or the S key down here. But that can be helpful when navigating through these cells. And then this is just a little bit of the interface that we're seeing here. We're working in these layers. rather than all in one space, you'll have to make sure that you're in the correct layer when you're adding or removing things or changing things. So we have the image layer, that's this EM image here, the segmentation layer, that's the 3D image, and then you can add annotation layers. Um, and that's where you can put annotations down to label the cells. When we do proofreading, we use the annotations a lot to mark branch ends as complete because we don't have the same kind of completion system as EyeWire 1 where you're sort of recoloring the whole branch. Instead, we're using annotation points to mark off ends of the branches as complete. We also have these various panel views. So if you want, you can extend this EM across the whole page, or you can extend the 3D across the whole page. You can also have multi-panel views. We have the Z, X, and Y axes, and you can have all three of those views in one panel if you so choose. And then we also have the share button. That's the most important thing probably to know about EyeWire 2 is that when you're sharing information, you always want to share the share button. We're basically sharing links. That's how we share instances of what we're working on. So in EyeWire 1, you might use the Scouts log to have an image and then write some information about your cell. In EyeWire 2, all your information is going to exist within whatever you're working on, your annotation points. You can write notes on your annotation points. And then if you want to give that to someone else to know what you were working on and what, labeling you had, you're going to always use this share button to send it over, and that will retain all of the information that you had locally on your machine when you were working on any given cell once you use the share. So that's an overview, I guess a preview of the new interface, um, just to give you guys something to think about when we're starting off on this, new project that looks a little different than EyeWire 1. Okay, so I'm going to pass it over to Simone to talk about the scientific value of the data set.
Yeah, thank you, Celia. So I will just let you know when I'm going to the next slide
Yeah, that
because
sounds
I
good.
cannot control it. Great. Yes, so I wanted to tell you a little bit more about why we are excited about the iWire 2 resource from a scientific perspective. So if you go to the next slide, so one thing that you've probably seen also in EyeWire 1 is that cells in the retina can come in all different types of sizes and shapes. And actually knowing how their morphology looks can tell us quite a bit about what that cell might be doing or how it would react to a visual stimulation in its environment. So one of our goals is actually to have a complete catalog of the different cell types that we have in the retina. So especially of the amacrine cells that Julia mentioned in the beginning, they are actually quite, they are very diverse in how they look morphologically. And we hope that we will discover actually quite a few new types that haven't really comprehensively been described before. So what you see here in this figure are a lot of cells in EyeWire 2, I believe almost 20,000 that we have already looked at. And each point here is a cell, and it represents like a summary of their morphology in a two-dimensional visualization. And what you can see very clearly is that cells form very distinct islands. So they really form groups that look significantly different from other cells. And there are some examples here, such as the on-starburst amacrine cells and the off-starburst amacrine cells that you are familiar with. And what EyeWire 2 also offers is that now we can look at cells that are really big, which have not really been described in the EM reconstructions before, that we can now also resolve and have many examples of. Um, Yeah, and as I said, also we hope to describe some of these cells that haven't really been looked at much before. Next slide, please. Yeah, so the second part that we're really excited about, and me personally, is what Celia mentioned before, that the resolution of the data set is a lot better than before. So we have labeling of the structures inside the cells. And what you can see here are examples of synapses between three cells talking to each other. And that is really valuable information to us because now we can really precisely look at which cell connects with which other cell and what are the circuits that are formed and with which the cells in the retina communicate with each other. Yes, so here on the very left, there is an example of two different types of synapses in the EM image. And then in the middle, you see the 3D reconstruction of that. And then with the full cell morphology, we can simply zoom out and we know which cell is talking with which one in the EyeWire2 data set. So that's really a lot of very valuable information for us because from that, what you can then see below, like one thing we can do is we can like extend our classification of a cell type with a synaptic input profile. So we know which cells receive information from which other cells in the structured retina. And another very exciting area that we're looking at, if you click to the next slide, Celia, please. Yes, so another thing that we're really excited about is to link all that information to the functional data that are connected, that are part of the EyeWire2 data set. So Celia mentioned that as well at the beginning. Many of the cells that are reconstructed have been recorded before, so the activity in response to a visual stimulation has been filmed. And now we have like that's part of the data set, right? So we have the full morphological reconstruction of a cell and we know how it responds to a visual stimulus. And we hope that if we put like every piece of the puzzle together, we can really recreate how a cell in the retina transmits or encodes a visual stimulus. And yeah, that will be very exciting for us.
All right,
Um,
great. Oh,
uh,
sorry.
I actually, yeah, I think I may
What
have
is
one
that?
more slide.
Oh,
Yeah,
yep.
let's see.
Okay.
Oh, yeah, that one. Yeah, so I wanted to mention that as well. So it's not just us that are working on the data set at the moment, but we actually have a group of, I think now it's 32 labs from all over the world that are part of the EyeWire2 community. And that each of them like have a specific cell type of interest or a specific circuit that they're studying. And they're using the data sets to look a little bit more detailed into the connectivity and help to answer their own research questions. So that's also very exciting to, yeah, to get in contact with so many different labs and see that the data set is really useful for many different research questions going beyond what we're doing. And now I'm done. Thank you, Celia.
Yeah, great. Thank you so much for talking a little more about the scientific value of the data set. Oops, I clicked off a little too quick. But yeah, it's really cool to see all of the people who are working and doing research on our data set across the globe. And it's great to have you guys come and contribute from the citizen science aspect as well. Okay, so that's a little overview of EyeWire. Does anyone have any questions about anything that we've talked about so far? About the cells or any of the data?
Yeah, I've got lots of questions, but I don't want to derail the presentation.
Okay. All right, that sounds good. Maybe we can have a few questions at the end as well.
Celia, let me just quickly say I have to go because I have to be somewhere at 12, but I put in chat a link to the demo that's very much work in progress of new citizen science game in Neuroglancer. There's a lot of bugs, there's a lot of issues, but I just wanted to share so you guys could see. You can click around. There's an attempt at a new tutorial that sort of gets stuck. But I just wanted to say thank you guys so much for all of the work and all of your energy that you've put into EyeWire over the years. And I feel like it's really helped catalyze the field of connectomics as a whole, and is essentially helping to usher in a new way of doing science where citizen scientists can work alongside researchers in collaboration to make everything move faster. And I'm really excited to see what's going to happen over the next few years. So thank you guys, and I'll see you online. Bye.
Great. Thanks, Amy. See you later. Okay, so this is the project that we're gonna get you started with, primary cilia hunting. And so this is a great starting project because it does not require any proofreading. So for this, we're just going to be finding and labeling cilia. Um, so here's an example of one coming off the cell. There is just one for each cell, and they always are going to come off of the soma of the cell. So that's some important, I guess, basic information to know about them. This is a little bit of information about the primary cilia. They receive and process environmental signals, serve as antenna that the cells use to sense the chemistry of their environment. And a lot we don't know about them, which is part of the reason that we're taking this project underway to help label the cilia on these cells and hopefully learn more about them in the future. Um, so this is an example cell. This is a pretty classic presentation of the cilia coming off of the cell. And then here we're seeing a side by side of the cell, and then this is another view where some of the opacity is turned down on the cell. I'm going to show you how to do that in a little bit, and then this is an example of how we want you to label the cell. We have this line coming through the cilia, the cilium, and then we also have a few more annotations down here, which I will explain shortly. Um, okay, so I'm going to leave this presentation briefly, and I'm going to go over to another presentation that we will provide you with later if you're interested in pursuing this project. Um, this is a very in-depth presentation about cilia and how to find them in our data set. I'm not going to go through the whole thing. You guys can read over the whole thing later, but I will go over some of the beginning parts of it. So here is a graphic of what the cilium looks like. So you've got the structure that is coming out of the soma, and then you have this basal body, which exists at the base of the cilium, and then a daughter centriole, which is this sort of piece that's connected, but also slightly disconnected from the rest of the body of the cilium. Um, and so here's what this looks like in the EM images. This ciliary pocket you may or may not see sometimes, but this is something that's going to be good to look out for as you're looking for these. And then in the EM itself, you're going to be looking for these kind of blurry circle or oval structures. And you can see them like a cross section of in this diagram. That's basically what you're looking at over here. Um, and so that's something that you're going to be looking for to be able to find these. As I'll show later, sometimes they're pretty like obvious and easy to find. Sometimes they're definitely not easy to find, and sometimes they don't project out of the soma, and you're only going to be able to see the internal centriole and basal body inside the cell. I'll try and play this movie and see if it works also. So here's an example of just going through the slides, and you can see the cilium exit the cell over here. So that's what you're going to look out for. It might be a little bit difficult when you're first starting to sort of get your bearings and understand what's happening, but after you do a couple of these, you'll be able to like know what to look for. And I think after a few of them, you'll be able to fairly quickly identify these structures that you're seeing. Um, okay, I think this is mostly saying the same thing. All right, so I'm going to go over a few examples of these. So here we are in Neuroglancer. This is EyeWire 2. This is what you guys are going to be looking at if you decide to pursue this project. So like I mentioned earlier, we have the different layer system up here. You can see if I click on these, they turn on and off the layers. So this is the EM imagery layer. This is the 3D layer. And then these are some annotation layers that were pre-added for this project. So they don't have anything on them right now. Okay, so this one is a good example of a pretty obvious cilium that is exiting the cell. There are some other small structures on this cell that could be mistaken for the cilium, like these little projections over here. But in this case, it's pretty obvious which one it is because it's, much larger and um, just kind of a different shape from the rest of the little projections coming off of the cell body. One other thing that I think is really something to keep in mind when you're looking at these is that the cilia when they exit the soma tend to have this little pocket right around where they're exiting. I think that we showed it here. Yeah, this right here, the ciliary pocket. So you can kind of obviously see those on some of these. This one's not super obvious, but you can kind of tell there's like a little divot around where it's coming out of the cell. Okay, and so now I'm going to inspect it in the EM. So you can see it coming out here. Let's see. So it's exiting, and you can see this is the structure that we're following here. And then as it comes closer to the soma, you can also see that sort of internal round structure that I was talking about. So that's the basal body. And then as I keep going, it kind of disappears. And then another one appears right here, and that's the daughter centriole. So the way that you're going to label these is I usually start with one of these. You're going to use an annotation point. You have to click to activate it. Okay, so I'm in the basal body right now. So I'm going to put an annotation point on that by control and click. And you can see that the color of the annotation point is the same as the layer. So to make sure you're in the right layer, just check that you're putting down the right color annotation point. Then I'm going to go over to the daughter centriole. Okay, I'm going to scroll through to find that. Click and put another annotation point there. And then the last one is the cilium center line. So for that one, I'm going to go to that layer, and then I'm going to use this annotation type over here, the polyline. And for that, you're going to control click to put it down, and then control click through the cell to put that down. I'm going to go a little bit quickly just to finish it up, but you guys should probably put a few more points than what I'm putting on this. Okay. Okay, and then to finish it off, you're just going to press enter on your keyboard. And then one thing that I probably should have done before was that you can change the opacity on these cells. So you can bring down the 3D opacity. That's the one that you want to work with. And then you can bring up this silhouette opacity over here so you can see the line that I put through it. And you should probably turn that down before you add these annotations because then you can see it as you're working. But that's just something to keep in mind. And you can also see where I put the daughter centriole point and the basal body point over here. Okay, so that's a very classic example of what you might see. This is like a pretty easy one. Like you found it, you annotated it, it shouldn't take too long. But not all of them are going to be that straightforward. So here's another couple examples. So in this one, it's probably not super obvious where the cilium is coming out of the cell. Let's see if I can even still find it. Okay. So, you might want to inspect some of these little protrusions. And when you do inspect them, you want to make sure that you're seeing those internal structures like I was showing in the last one. So here we have one that is exiting the cell. Right here, but if we look in this area, I'm not seeing any of those hallmarks of it actually being the cilium. So in this one, the cilium is actually right here and it's kind of hugging the cell body. And one thing we can see is we can see that little pocket that I was talking about earlier. So that is visible. And then this is the cilium coming off of it right here. So if we check the EM imagery, you can kind of you can see those structures right here. Another thing to keep in mind, I'll turn this EM coloring off for a minute, is that the centrals tend to be kind of being hugged by the Golgi body, which are these little sort of squiggly circles and lines, dark dark apparatus that is right here. And there's multiple ones in the cell, but usually the cilium is, or the centrioles are going to be surrounded by some of this stuff. So you can kind of see this like empty pocket with this area in the middle. That's what you want to be looking out for. So I can see that here. So that means that we're on the right track, and then it's exiting. And then this one, it has an incomplete one. So I'm going to click it, and you can see it added part of it here. And then I'm gonna just keep going and see if there's any more to add, and there's not on this one. So for these, you can choose to keep in this secondary segment or not, but you do want to make sure that you, when you're annotating the cilium center line, to make sure it goes through that whole structure and it doesn't just stop at the place where there was a break here. So that's the second example. And then for the third example, um, for this one, you might want, like in this example, maybe I looked around at this cell for a while, and tried to find something. But in this example, you actually cannot see the cilium exiting the cell. And so in this case, you're going to need to use just the EM to try and find it. So I'm going to do my best to try and find it again, now that I uh, have all the annotations turned off, and I will just show that. So for these, I suggest that you go to the EM only view. You don't have to, but it'll give you a wider area to inspect. And sometimes I also like to turn off the coloring so you can press 2 to hide the layer, the segmentation layer. So I might turn that off just so I can get a better view. And then just scroll through the cell, and I'll see if I can find it real quick. We'll see.
While Celia's looking here, I'll mention that you'll notice when Celia was looking at the cilia that were present, outside of the soma there, that we saw them actually sticking out, that they were just long, skinny tubes. So they don't have anything like a bouton at the end or something. So that's a great way to kind of cut down on some of those little pieces that you might be seeing out of the cell. And then in the case of right now, while Celia is looking here, um, it kind of we'll start looking at the different areas where we see those kind of crowded Golgi spots that she mentioned earlier as well, for where to find kind of the cilium. So that's
Um,
yeah.
yeah, that's Celia. All right. So I think I've located it here, and if you can see, just kind of looking at the overview, there's this sort of empty space within the Golgi right here. So that's how I was able to sort of notice that this is where the central pair is. So there's that one that's like pretty obvious. And then if I keep scrolling, see if I scrolled in the right direction, maybe I didn't. Um, Okay, so here's the other one over here. This one's not as obvious, but since there's two of them, hopefully you can at least locate one, and then the other one is usually nearby. So this is the other one. It's kind of a more oblong shape. It's going through more slides, but you can kind of see it over here as well. And then the more obvious one is right here. Okay, and then I think that these were labeled already. So there's the daughter and the basal body. Um, and I'll go back to the 2D layout and the cell, and I'm going to turn down the opacity on that again. So you can see on this one, this is how you'll label one of these ones where it's just an internal centriole pair. Sometimes you might not be able to really know which one's the basal body and which one's the daughter. So I made my best guess on this one. I chose the basal body as the one that's closer to the surface. I think that's generally a good bet since, they're kind of attempting to go towards the surface. Um, and then you'll just make a note that this is an internal centriole pair and there's no cilium exiting the cell body. So yeah, that's the three types of cells that you might see, the really obvious ones, the ones that are not obvious or less obvious and that maybe need an extension, and then ones where you're not seeing anything and it's just internal to the cell. Um, so yeah, and so for these, we're just using annotations. You don't need to be permanently adding or removing anything from the cell. So that part shouldn't be too bad. And I think that even if you maybe have some like hardware limitations, I think being able to load up one cell and just annotate it probably in most cases should be doable. And if you're still having any issues, we do have some settings that you can change to make it a little less hard on your system to work with. So,
And I think the other thing too is I know like sometimes you worry about time or something, but you notice that we just jumped through three examples really quickly in the past, what, 10 minutes? And that's even with Celia explaining things. So it's a really nice way to kind of just do some quick little kind of cube finding, as it were, without, having to think about, sitting down for a long time. So it's a good transition point from being used to doing, a cube on EyeWire 1 to just being able to find these. And I think, some folks may have a question of, well, why hasn't the computer been able to find these or anything? Well, as you saw with what we just provided with the examples, they can be very faint or very difficult for the computer to differentiate. So we obviously need to go through and do these all by essentially hand, and that's where folks like yourselves are going to be very valuable for being able to contribute to helping us with this. And there isn't much known about them, as Celia kind of mentioned briefly at the beginning of the this part of the presentation here. So it's pretty important for us to kind of understand and learn more and mark these. And that's a big contribution for anyone who wants to join on the project. So sorry, Celia, I took over a little bit.
no, no, thank you. That's helpful.
Give your voice a rest.
Yeah. Yeah, and I like honestly I've like done some of these and they are kind of like fun. I feel like when you find them, you're like, ooh, I found it. Like it is kind of a fun little project to be working on, and I think it gives you a good starting point to be exploring the EM imagery in our new data set and looking at some of the internal structures. I think that's pretty cool as well. Um, okay, so let me go back to the presentation. Okay, so next steps. If you haven't filled out the form, it's this access form. I suggest you do that. I guess I'll take out the section about the intro session since we've already done that. But this is basically to get access to the data set, you'll need to agree to the principles and add a Google account email address. We need that information to be able to get you started. For the people who have already signed up, I'll give you access after we finish up this session. And then you should have access. If you have any issues with it, being able to jump into the data set, you can let me know. And I'll also send out the sort of intro Cilia, first couple of things that like trial that we have for you guys after this. And then the Cilia guidebook is just this presentation that we have. So will be shared. I'll share this the slideshow with you guys after the meeting. And then, yeah, this is the last thing is the practice test where we'll have you do some of these Cilia examples just to get started, and we'll give you feedback on how you did on those after you've completed it. So that's the next thing. And let's see. Okay. I think Amy also wanted us to share
I think she
her
shared it in the
demo.
chat.
Okay, she
Oh,
did.
oh yeah.
Yeah, okay. So I'll share that briefly. Hopefully I'm already connected to it. Ooh, hold on, just give me a second.
Yeah. And I know we're going over the hour a little, so if folks need to head out, no worries. We're recording this. And um, yeah.
Yeah, I'll go over it briefly. Okay. So so this is on a different data set. This is on the tutorial data set, Pinky, but this is some stuff that we've been working on, that Amy's been working on. So this is a demo site, it has a chat. I think there's a leaderboard. See if I remember. So there's a little leaderboard, which is fun. Um, and profile and achievements. So that this is still in the works. We're still prototyping this. But these are some things that we're hoping to be able to add to the site eventually to make it a little more fun and to have everything all in one place. Rather than working off of spreadsheets. So that's hopefully something we'll have in the future. This has a way to label cell types and mark them as complete, which we don't currently have available on the site. So that would be great also. And there's some various other things up at the top. Um, so this is sort of a Scouts log type thing. So as you can see, we have a lot of ideas and a nice prototype, and hopefully at some point we'll be able to get some of these features out to you guys as well. So something to look forward to going forward. Okay. And then go back to the presentation. Um, okay, so yeah, this is just a little bit about that. Our future hopes. So that website is definitely some of the features from that we definitely hope to add. In the future, we'll be adding more data sets and also proofreading projects. We already have some citizen scientists working on proofreading some cells. So if that's something you're interested with, once you get comfortable with the Cilia project, we're happy to help you also get edit access to the data set and start working on some proofreading projects as well if you have an interest in that. And we also plan to have a community hub in the future for all of our projects. So those are some things to look forward to going forward. And last thing is thank you. Thank you for being part of EyeWire, for being part of EyeWire 2. Our community is great. I feel like we have, so many amazing people who just love neuroscience or they love puzzles and they're, super excited to be working on these things. And we really appreciate you guys and we appreciate the community and how helpful you guys are and collaborative. And we just want to say thank you so much. And of course, for science. Um,
I
So
don't have
yeah.
that translated for me, so I'll have
Yeah,
to get
the
the bot.
wonders of heck of this. Um,
Yeah.
all right, so yeah, that's an overview of EyeWire and the new project. Yeah, if you guys have any questions, I think now is the time to ask. Um, Questions in the chat. Um, uh, no consensus. We basically, you know, have training,
Okay.
have like, all you guys are coming in with already training from EyeWire 1. There will be more training doing this like uh annotation project, and then by the time we get to proofreading, we have people who have already been trained and we trust them to make correct you know branches for the most part, or connections for the most part. And we also rely on people asking for help if they need it. So if you're like really having trouble, you can't find an extension, we assume that you're gonna be like, hey, can anyone help me with this? And collaborate in that way. And then, as Marissa mentioned earlier, we can always go back and correct things that need to be corrected uh, if those are found in the future. Um, or if like somebody's looking at specific cells and they're like, hey, we really need like a second cleaning of these cells, then we might do that, something like that.
Um,
Um,
do you mind if I go through these real quick, Celia?
yeah,
I
go
can
for
answer
it.
a lot of these real quick from
Sure.
one thing about the how do you make sure nobody's adding the same thing at the same time? It's possible, but every edit is made in real time and it's real time updated. So we just suggest to people a best practice is to basically make sure they have the most recent version of a segment ID, and that'll get explained in like the proofreading process. But basically, anytime you deselect and reselect that segment, in the EM, it's the most recent version. So let's say if you were to be, adding in a branch and suddenly you're getting some errors with being like, hey, this branch is already, it will give you an error that this, segment is out of date or it's already been edited. So you kind of get those already noticed for those things. Once the AI model has been, it's basically this is what the segmentation is for the particular data set. So that's pretty much set. And so that's where we come in to finish that last 10%, as I explained. For number three, the research is, constantly ongoing. People still refer back to old data sets and old papers, and, that's why it's not outdated. Yeah, there's, plenty more to do. And we even mentioned E2198 is still being used for EyeWire that we're looking at. And remember, that launched about 14 years, 12, 14 years ago, and it's still being used as a comparative data set. Number four, you can zoom in as far as you were seeing with Celia just now doing the demos for the Cilia demonstration. You can get all the way in deep if you want, so you can zoom as much as you want. Um, for who's working on what cells, that's where the spreadsheet comes in, and sometimes that's where, we're always trying to kind of work together on that. So that kind of answers your questions for 5 and 6. And for 7, yes, EW2 has similar to zebrafish, where there is one direction that is better imaged, and the other two are composited together. So it's not as well done as the kind of cube 3 different axes that we see in EyeWire. However, almost all the data sets nowadays are like that. So we find that that is not too much of a restriction now that we mostly have only one view. Um, and Unfortunately, for this software for NeuroGlancer, we have done our best to make it as accessible as possible, but it is a software out of Google, so we don't actually kind of like control that software, and the best we can do is put skins and things like that to make it more easily to use. So we kind of have to have a conversation with the developer of this software to make any of those changes for commands. So that will is we do our best to explain how to handle those in terms of the tutorials. Um, And yes, for the celium, yeah, it's possible that that's why there needs to be more research done on them for your number 9 question. Um, and I think everyone else is saying they got to head out. So thank you everyone for joining. If there's any other questions for anyone else remaining, just let me know.
All right. Thanks for joining, you guys. We appreciate it, and we're looking forward to having you help out on this project and other projects in the future for EyeWire too.
Yeah, thank you.
All right. See you guys.
Thanks, everyone. Bye.
All right. Thank you.
Bye.
Thank you. Bye.
Bye.